Hi everyone, let's do an example of this right triangle trig. Okay, let's say that theta is an acute angle such that cosine of theta is 4/7. Find all 6 basic trig values for theta. So I'm giving you one of them. Find the other 5 and remind us of this. Okay, we have enough information. We can find sine of theta and all of the other buddies. Now, first of all, it's helpful to sketch a right triangle model. You don't need a ruler to do this, but make sure that longer side lengths do in fact lead to longer sides when you draw these things. In particular, the hypotenuse must be the longest side. So let's sketch a right triangle model. Let's say that we have this right triangle. It's good to indicate the right angle with a square. Here's our angle theta, one of the two acute angles. Let's take this angle theta, and we're given that cosine of theta is 4/7. Now remember, cosine of theta is adjacent. I'm going to type this. Remember that cosine of theta is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse. Now, instead, you could have done this. Cosine of theta is 4/7 over 1. This would work, but I would think that we would want to avoid fractions right now, so this might make things a bit easier. Okay, it turns out that the missing side length will be root 33. If we want, we could assume these are all in meters. Let's assume a common unit. Okay, so we can assume that these are all in meters. It turns out this will be root 33. How do we know that? How can we find this out? From whose theorem? Mr. Pythagoras. Again, it wasn't his theorem, really, but it was named after him. The Pythagorean theorem. Okay, bear in mind, we don't have a Pythagorean triple here. It's not a 3, 4, 5 situation. If that were a 5, then we'd have a 3 here, right? The Pythagorean theorem. X, the unknown right now, x squared plus 4 squared equals 7 squared. Now, a lot of students are tempted to do x squared equals 4 squared plus 7 squared. They love to isolate x squared on one side. But here, sorry folks, but the x squared is buried in there. If you try to isolate x squared right now, you'll probably get it wrong. Okay, so what are these squares? We have x squared plus the square of 4 is 16 equals the square of 7 is 49. We're solving for x squared and then x. What do we do with the 16? We subtract it from both sides. Don't say move, say subtract. We subtract 16 from both sides. X squared equals 49 minus 16 is 33. And then we apply the square root method. If x squared is 33, then technically x can be plus or minus the square root of 33. But since theta is an acute angle, we're going to use the positive number for this. Now you might be saying, well, hey, aren't lengths always positive? Well, yes, but it turns out that if we move to other quadrants, we sometimes use signed lengths. We sometimes put the negative number. For example, if this were a triangle in quadrant 3 or quadrant 4, we'd put a negative root 3, a negative root 33 down here or down here to label the side. But since theta is acute, we always take the positive number for our indicated length, our indicated signed length. Okay, so we take x equals root 33, which is simplified. Again, if we have 4 meters here and 7 meters here, this would also be in meters. For right now, I'm not worried about units. Okay, so we know now that this missing side length is root 33, meters or whatever. Well, that really unlocks the whole puzzle for us. If we know this missing side length, then we can get all the ratios we need. All right, so let's do it. In fact, it might be a good idea if I take a copy. Yeah, so let's keep this up here. I'm going to keep this up here, and I'll use my copy of this file. Well, here we go. Here we go. All right. Now, remember, we were given, right off the bat, we were given that cosine of theta was 4/7. Okay, we were given this. But now we can figure out the other 5 ratios. What about sine of theta? Sine of theta, remember SOHCAHTOA. Sine of theta is opposite over hypotenuse. Relative to theta, opposite is root 33. In fact, I may as well say this is opposite. Okay. And this is adjacent, the 4. That's going to be adjacent. Let's type it in. Okay, that's adjacent over there. Opposite over here. And the 7 here, remember, is the hypotenuse. Okay. Relative to theta, here's the cast of characters. This is the hypotenuse regardless. Okay, here we go. Sine of theta is opposite over hypotenuse. It's root 33 over 7, and that's simplified. You may notice this is less than 1. Root 36 is less than 6. Cosine of theta is 4/7. We made it so. Tangent of theta, SOHCAHTOA. Tangent of theta is TOA, opposite over adjacent. Opposite is root 33. Adjacent is 4. Tangent of theta is root 33 over 4, and that's simplified. Okay, now from these, we can get the 3 reciprocal values. The reciprocal of sine of theta is what? Not secant of theta, it's cosecant of theta. The reciprocal of sine of theta is cosecant of theta. We flip this fraction. We get 7 over root 33. But what's our problem with this? We can rationalize the denominator. We multiply by 1 in the form of root 33 over root 33. We multiply fractions across. 7 times root 33 is 7 root 33. On the bottom, root 33 times root 33 is 33. And you see here that this is simplified. 7 and 33, we can't do any reduction there. This is cosecant of theta in nicest, simplest form. Remember that if we have the square root of an integer down in the bottom, a non-zero integer, then we tend to rationalize the denominator. In fact, let's say that that's typically required for these trig problems. When would we not rationalize? If we have, for example, 1 over the square root of x, well, x itself could be an irrational number like pi or something, so we tend not to rationalize the denominator in a situation like this, where we have a variable or potentially irrational radicand. But here, 33 is an integer, we tend to rationalize. This is easy. The cosine of theta is 4/7, therefore its reciprocal, the what? The secant of theta is, flip this, 7/4. Remember, cosine of theta cannot be greater than 1. This is 4/7, but secant of theta, in fact, will tend to be greater than 1. Here it's 7/4. If cosine of theta is less than 1, secant of theta will be greater than 1. No surprise there. Now for tangent of theta, we have root 33 over 4, so it's reciprocal. The cotangent of theta, we start by flipping the fraction. It's 4 over root 33, but we have an integer inside there, down there. So we rationalize the denominator, multiply by, again, root 33 over root 33. Remember that whole thing there is 1, right? This whole fraction here is 1, so that's legal. We multiply these and we get 4 root 33 over 33. That's the cotangent of theta. So in blue, I'm going to circle our final answers. Sine of theta is root 33 over 7. Cosine of theta, that was given, 4/7. We made it so. Tangent of theta is root 33 over 4. The reciprocals here, cosecant of theta is 7 root 33 over 33. Secant of theta is 7/4. Nice rational number. Cotangent of theta is 4 root 33 over 33. And voila, we have our 6 basic trig values for this acute angle theta. If theta were not acute, it's possible some of these might be negative. All right. So now, in our next video, we're going to look at the sine, cosine, and so forth for special angles, like 30 degrees, 60 degrees, and so forth. And where do those values come from? The sine of 30 degrees, where did that come from? We'll see the answer in the next video.